Hello children, it is a new unit, spectrum. You know already the deviation produced by the triangular prism. Let's recall it. It is very important for further subtopics in this unit. Here the prism, it is made up of already you know 5 surfaces, 2 triangular surfaces, front and back, and again 3 lateral surfaces inclined with certain angle. This is called as the angle of the prism. ABC is the principal section of the prism. Here I am taking the one ray, light ray, single ray, which is having a single color, monochromatic light. Whenever the monochromatic light is incident on the surface AB with a angle of incidence I, making it with normal. Q is a particular point, it is an incident ray. PQ is nothing but an incident ray, I is the angle of incidence. And again you know, whenever the light ray is passing from the air medium to the glass medium, here the interface here, it is a glass medium, so that medium changes. Here the light ray passing from the rarer medium to denser medium or air medium to the glass medium, the refracted ray is bending towards the normal. Bending towards the normal, but without prism, the entire light ray incident with the dotted line here, this is some of the angle is deviated, so that is called as a delta 1. Delta 1 is nothing but the deviated angle whenever the light ray is strikes the interface from air to glass medium. Next at the same time, this is a refracted ray Q to R, and again it falls on the surface AC. Here the medium changes, here the completely glass medium only. Whenever the light ray is passing from the glass medium to air medium or denser medium to rarer medium, it is a ray, RS is the ray emergent ray, making an angle delta 2 with the normal. This is the emergent ray. It is just away from the normal. So this angle of deviation is, if you extend the incident ray and again extend the backward emergent ray, then both are meeting at a common point. The angle between those two is nothing but the total delta. Delta is nothing but the angle of deviation. Angle of deviation. That angle of deviation is sum of the angle of deviation in the first surface and again the sum of the second surface. Here the delta 2. Delta 1 plus delta 2 is nothing but the delta, that is the total angle of deviation. That is the entire theory related to this one. As shown in the figure, when a light ray PQ of single color mean monochromatic light enters a triangular prism ABC, it gets deviated say by an angle delta 1 towards the base. The refracted ray is towards the base. And again at the first surface AB of the prism and travels a straight line as QR inside the prism. Inside it is a straight line because of it is a glass medium. Medium does not change. The angle of deviation delta 1 depends on the angle of incidence. This delta 1 angle of deviation will be depends upon the angle of the incidence and also the refractive index of glass with respect to air. Glass to with respect to air, the angle of deviation will depends upon those two factors in the first surface. The ray QR gets further deviated say by angle delta 2 towards the base BC. Again it is towards the BC and travels straight as RS outside the prism. Outside the prism it is always travels towards the BC. The angle of deviation delta 2 depends upon the angle of incidence of the second surface. Again here the angle of deviation delta 2 will be depends upon the incident and also which depends upon the angle of the corresponding prism. Then which depends upon the angle of the prism and the refractive index of air with respect to glass for the total emergent ray. The angle of deviation is equal to the sum of the angle of deviation. Delta 1 plus delta 2 is the first surface angle of deviation. It is the second surface angle of deviation. And again you already learned that is entire thing. Angle of deviation will be depends upon the angle of incidence of the first surface Next, angle of the prism, and also it depends upon the refractive index of the material which is made up of. Prism will be made up of a certain material. Its refractive index, the angle of deviation also depends upon the refractive index of the corresponding medium, and also the refractive index of the medium is depends upon the wavelength of the corresponding light you are using. Just for convenient, we are using only monochromatic light. We have a single color. It is only single lambda. It depends upon the lambda also. Angle of deviation will be depends upon the wavelength also, because of the refractive index also depends upon the wavelength. Next, dependence of deviation on the color of light or wavelength. Here I am not taking any single monochromatic light. Here the white light. White light is nothing but the, already you know in the previous classes, means last standards, the white light is mixture of 7 colors. We will understand the concept here also. The light of different colors have same speed in air but different speeds in the medium. If you take the white light, in the air medium it is same. All the colors will be travel with a unique speed. But if the medium is changes, within that it is different speed. The color having the different speed. Different colors have the different speed. If the light entering the prism is not of a single color, it is a mixture of several colors. It is a combination of the number of colors. It is not a monochromatic light. It is a white light. Then the emergent beam also has different colors arranged in the definite order. After, whenever the white light is passed through the prism, if you place a screen other face of the prism, then if you know that if you see the something like a different colors in the specific order, it is because the speed of light in transparent medium decreases with the decreasing in the wavelength. Decrease the wavelength, the speed also decreasing in transparent media, any transparent media. So the refractive index of the glass or material of the prism increases with the decrease in the wavelength. If you decrease the wavelength, the refractive index of the corresponding media is increasing. Next, the deviation caused by a prism also increases with the increase in the wavelength of light. It depends upon the wavelength also, because of the refractive index. The deviation caused by the prism, how much deviation is produced by the prism, also increases with the decrease in the wavelength of light. Decrease the wavelength of light. Already studied in the last second unit the relation between the refractive index and again the wavelength. In visible light, violet color, it is having the refractive index is some value, and also it is having some wavelength. It depends upon the color. The 4000 angstroms is deviated the most, and red color wavelength is 8000 angstroms is deviated the least. The red color is deviated the least and violet is most deviated, because in glass medium the speed of the violet light is least and that of the red light is most. The speed of the red light is most. In the case of the transparent media, here the prism, it is made up of glass material and the violet speed is least, so that the refractive index, we can compare with the help of the refractive index also. Refractive index for violet color is more than that of the refractive index for the red color. If you compare the any visible light, violet color refractive index is more than that of the red color, so that the angle of deviation is highest for the violet compared to the red in the visible light or visible spectrum.